Alright, let's do this. Oh wait, hold on. Just need to spam advertise myself a little, make sure people are coming to tune in. Alright, perfect. So, welcome back. This is PlayStation 2 homebrew development. I just banged my microphone. We're gonna go huge today, okay? So, I don't know if people remember. Let's build what we had last time, okay? For people following along at home, I've got this all going up into a Git repository. Let's start things off. We'll build. I have actually had a helpful tip from a wonderful viewer that we can actually just run things in PCSX2 directly. There's an elf equals, if we just go test.elf, yeah, we can just start up PCSX2 and that'll run our code. And there are some issues, which is kind of weird. Let's make clean first. Already hitting a weird issue today. It's beautiful. Weird. I must have done something. I was playing around with a few things. I wonder if I accidentally committed something to this branch. This looks fine. Anyway, we're going to play around with this. We're going to tear all this up anyway. So last time we drew triangles to the screen and it was the most exciting thing ever. Today, I want to do two important things. I want to start to refactor this a little because this one source file is really, really messy. The other thing I want to do, I've got this file here. I've got cube.gif and teapot.gif. These aren't like GIF image files. This is what I've called a special... I've taken object files and I've pre-processed them into a format that the PlayStation 2 can kind of understand. I'll talk about this in a bit, but basically I'm going to try and get some models drawn to the screen. And because, I don't know, parsing object files is kind of gross in C, so I've written a Python script to pre-process it, get things into a format that the PlayStation 2 will like, and then we'll go from there. Just to make things a little bit easier for ourselves when it comes to loading and whatever. So, first things first, new branch. What's the date today? 2021-08-08, I believe. So, we wanna move some of this graphic synthesizer code into its own file. Let's make a file, gs.c, and let's move. We can move finish and init over. That's gonna be really, really easy out the bat. Like, there's not much to consider here. This zbuffer variable is going to be the bane of our existence because we need it not only when we initialize the graphic synthesizer, but then we have to pass it to this disable and enable test function as part of our draw clear. So we're gonna have to think about how our data is gonna flow here. One option is that we could kind of wrap this up, I guess, and put it. I don't really like the idea of putting this in our graphic synthesizer, right? We want to have a file, we want to have gs.c, we also want to have a file called like draw.c or something, which has our actual drawing code in it. And we also need to think about this, right? We can't do this, and we can't do this, because we don't actually, like, this buffer was in file scope. So there are some things we need to think about. How do we actually pass a buffer into these functions? Do we just pass a buffer in and say this is memory you can use to do a DMA transfer? Do we have something at file scope for this file? That's probably not too bad of an idea, because I want these functions to kind of be independent. I want these functions, like if you're calling finish, do we actually call finish? Okay, well, we never actually call this, so I guess refactor number one, let's just axe this function. That makes our life simpler. That makes our life much simpler. But this is a bit messy, right? It does a lot of things, and there's this critical part which does actually need a buffer. It needs a memory from somewhere. So, my thought is to maybe have a drawing environment struct that we pass into GS methods. That way, we have a consistent way of, like, holding onto our frame buffer, or at least the information associated with our frame buffer, of holding onto the information associated with our Z buffer. We can pass it to other functions as they need them. So that's going to look something like this, right? GS or draw maybe we'll go like huge with this. We'll have a frame buffer t fb. We'll have a z buffer t zb. What else do we need? We need maybe some kind of generic buffer that can be used for this kind of drawing. Let's do that for now. And so this will be like a special buffer that's only used for things like GS and net and code that... Actually, no. Let's not. That's kind of crossing our concepts here. Let's make not a static. Actually, no. Yeah, a static list of, or a static array of keyword t's. Let's call it GS command buffer. But it's not going to be initialized to anything. This is the key here. So as part of GS init, we will malloc this buffer to something. So thing number one, GS cmd if not GS buffer, then we'll malloc it to some magic predefined size. Let's say 150 bytes. Oh, hold on. Let's say 40 times 16. That sounds like a reasonable number of bytes. That sounds like too many bytes. GS cmd buffer len. Beautiful. Cool. So this gives us memory we can actually use, right? So keyword q, rather than buff, it's GS cmd buffer. So I called it, yeah, GS cmd buffer. Now everywhere we have buff in here, GS cmd buffer, draw primitive offset, GS cmd buffer, GS cmd buffer. Perfect. So now we have a dumb file scope variable, but this is going to make things a lot nicer. This is going to make things a lot nicer. Cool. So frame buffer. Now instead of just having a frame buffer kind of defined here, we'll pass in, I guess, draw. We'll pass it in. Oh man, someone in my chat told me how to do this not like an idiot the other day, and I have promptly forgotten. So I'm typing this all out like an absolute scrub. Yeah, multi-cursor stuff is where it's not really multi-cursor, but like doing the same thing on multiple lines is really where my Vim knowledge ends. I did a really cool search and replace the other day. I can't remember quite what it was. I had like a bunch of numbers I needed to change, and I was able to like write a pattern that just matched that many numbers and then replace them with something more meaningful. It was cool. I love it when you can like pull out a really cool Vim one-liner. Okay, now rather than FB, it's DS FB. We've got this idea of just like state. And actually maybe instead of passing in width, height, PSM, PSMZ, first off, let's store a width and a height in here as well. This is getting crazy. This is getting crazy. PSM and PSMZ I think can happily, I mean, well, these are actually stored in the frame buffer. I feel like width and height is something kind of more universal than just what our frame buffer is about. And V mode and G mode, yeah, like that's actually probably something we want to store as well. So let's say int V mode, int G mode. Cool. And now we just need to update all of the references. So DS width. I could do this automatically, but I do like to, in this instance, I do want to go through line by line. Like I can't just replace every instance of width with DS width because like there's this field here. Graph VRAM allocate, DS width, DS height. Beautiful. And we're going to have DSG mode, DSV mode. We're going to get our width and our height from the draw state. So we're going to get our width here from the draw state. It's really interesting that this only cares about the width, and I'm kind of still getting my head around some of the subtleties of why the frame buffer... Well, I mean, the frame buffer just like doesn't bounds check for you, right? It makes you bounds check yourself. So, draw setup environment. This all should still be fine, except now we do we check the width and the height against this instead. Isn't this nicer already? Like, we actually had a variable here for this, and we were using some weird global defined weird file defined constant. Now it's actually like part of our arguments. That's beautiful. That is beautiful. So now we have a much nicer function with a much better defined kind of scope. We're going to go into gs.h and move this struct in here. Make ourselves a nice, if I remember what I'm doing. If gs.h isn't defined, then we're going to get this struct. We need to also define this function here. Beautiful. Okay, so this should still compile, I think. We need to include gs.h. And then we also need to include at least one other header here. Here we need, I think it's include is it a GS header or is it draw? I think draw.h gives us frame buffer t and c buffer t. Maybe graph.h. I can never remember exactly which headers these are. We definitely have graph.h. I'm going to commit to it being graph.h. I'm pretty sure that's it. And then we also have, we're using keyword t here, and I can't remember where keyword t is defined. So let's workspace PlayStation 2 PS2SDK grep RNI type def. Let's just search for keyword t. This is going to have a lot of results. Can I define keyword t? Oh no, hold on, here it is. Here it is. It's in tamtypes.h. This is actually, conveniently, the last match is our definition. Let me just do a quick check. Audio is on. Everything seems to be okay, which is excellent. Cool. Sorry, I just like to make sure that everything is working here. It can be very hard to tech check your own stream while you're going. Sometimes you like get in the flow and then realize you've been talking to no one because your microphone's been muted for like an hour or something. You know those vibes. Okay. Oh, hypervisor. Thank you so much for tuning in. Stream is good. I love to hear it. Thank you so much. Beautiful. Okay, then let's smash this. Stream's awesome. Trying to follow along. I'm in this weird place where I'm trying to go fast, but also trying to explain things. If you have questions, please do ask them. I will try my best to delve into things. But again, PlayStation 2 stuff is really complicated. If you're only following along in the broad strokes, that's really cool as well. Include tam types. Okay, so we've got a graphic synthesizer abstraction in the works. That's very exciting. So the next big thing to tackle, I mean, first off, this draw function is just going to go, right? We're going to put that in the bin pretty much. Draw buffers you sort of have around. Draw buffer len. Well, draw buffer doesn't exist anymore, so we're going to get rid of that. We're going to get rid of, we're going to keep these defines. They're okay. Offset X and offset Y, are we using them in that other file? We are not. Oh yeah, we've got 2048 hard coded, so hold on, let's 2048 define GS offset Y 2048. We worked out some stuff in the last stream with these magic numbers. It's basically just like giving us nicer coordinates to work with. Offset X and GS offset Y. I do want to rewrite this at some point to use a better buffer abstraction, but we are not quite there yet. So let's compile this and see if it works. It won't. There are a few last things I need to clean up here. So buff, we can get rid of... Actually, we can't quite get rid of buff, can we? We still need it to actually draw. But draw buff len only referenced here. So let's just like be really cheeky. 100 times 16. F minus 248. We'll live with that for now. We need to make a favorite new structure this draw state. So let's make it here. Z can go away. Struct draw state st equals. Now, what are our fields? Width, height, vmode. Vid w. I can never remember the exact syntax for struct initialization like this, so I hope I'm doing this right. Vmode equals graph get region. Gmode equals graph mode interlaced. What else do we need? We need a frame buffer t and a z buffer t. We probably just want to zero those out, don't we? So actually, I don't know. I'm a bit of a scrub when it comes to C-struct initialization, so there might be a better way to do this. But we'll zero it out for now and then actually manually set the fields. Cool. Okay. And then now when we GS init, we just pass this in and the PSM, which is the pixel format for our frame buffer and our Z buffer. So it's going to be ST, and then we just get rid of everything else. Beautiful. So if I build this now, it should work. And we get a bunch of warnings because I didn't actually include the new file, so that's to be expected. Include gs.h. That's a decent amount of errors. I like that. Okay, buff undeclared because we haven't actually declared a buffer. It doesn't actually matter where we declare this anymore. Cool. Z is undeclared. Of course Z is undeclared. We need to use the Z buffer we store in our state, and we need to actually pass it by reference, not by value. Where's this K come from? Beautiful. What was the other error? Vmode is unused. Of course it is, because we're not doing that anymore. And undefined reference. Oh yeah. We need to actually link our stuff together. So gs.o. And gs.o has a few errors because we haven't actually included draw. Oh, we've got this Z floating around. That's a problem. Draw finish. We need to include our DMA headers. Oops. We need our DMA headers, and let's grab these two. And we need draw and graph. We need everything. All right, let's see how that goes. Oh, and it's this variable not used. We also need memset, which I think memset comes from strings, right? gs.c include strings.h. Thank you. And then there's this z. Where's this hanging around? Here. ds z b, except it is going to be a reference. Interesting. Incompatible pointer type. FB. Oh, FB is undeclared. Of course FB is undeclared. And also we have this drawbuff length hanging around. So that's going to be GS CMD drawbuff length. Thank you very much. Is that what or even GSCMD bufferlen. Cool. So this is looking so much nicer. And we just need DSFB. And this is still giving us a few errors, masking something not a structure or union. So do we not have frame buffer t is of type int? We definitely have a frame buffer t here though. If I gs.h, it must want draw.h instead of graph.h. I must have gotten my things wrong. Yeah, there we go. So the problem there, sorry, I didn't really do a good job of talking about what the actual problem was. Oh my, I'm still getting used to having Vim keybinds on my ZSH shell. I'm not really used to using the ZSH shell. Okay, so what happened there, it was saying that this was an integer rather than a frame buffer t or a z buffer t, like these things, which is weird. And that is basically because, as far as I know, the compiler falls back to calling things an int if it doesn't resolve a type for it. So I just hadn't included the right header. Beautiful, beautiful. Few last things here. Implicit declaration of malloc, easy to do with. Include std, it even tells us exactly what to do. Malloc, that is cool. I actually also don't have a semicolon there. And then line 28. So 28 ds. Spelling mistakes, bane of my existence. Lib.h. Went on autopilot there. Expected. Oh yeah, line 25 as well. My bad. Beautiful. Okay, so let's run this in PCSX2 test.elf. See what happens. Lots of TLB misses. I don't know what is happening here. Syscall undefined. Weird. Someone actually gave me something to run for this, and when they did this, let's just make a rule run PCSX2 elf equals. They did pwd/eebin. So they gave it the current directory as well. I don't know if this is like a host file thing or what, but we'll see. You can also pass no GUI, but I actually want the GUI because then I can open the debugger. So let's make run, see if that actually makes a difference, and it does. Okay, so that's cool. Just do what other people tell you. That's great. So we've got a triangle running. You can figure out, yeah, that's a really good point as well. But in this case, I think I was just running. I don't know. Why do I have to pass in the whole path of the elf? Why can't I just give it like the path on its own? Is there something magical about the path? It's weird. But well, it's weird that would lead to TLB misses and stuff. It must be like loading garbage data somehow. I don't know. So let us. Oh, my laptop isn't plugged in. Just a second. Cool. So let's add these files to Git because that's always nice to do. gs.c, gs.h, git. And let's just say git amend. Let's get rid of that horrible colon. Perfect. Okay. Cool. That feels really good. Let's get rid of this sneaky file there that I was playing around with before the stream started. Oh boy. So, what next? What's the next low-hanging fruit to clean up in main? Like I said, I don't really want to clean up draw because I'm going to redo it. So let's talk about how I'm actually going to load models in to draw them. So as it stands, right, we've got this draw function. It's working really well. It's putting one whole amazing triangle on the screen. The next thing to try and do is to add more triangles, right? And I could do that by hand. I could hard code them into the binary, but that's kind of shit. So here, you know, we're building these packets, right? We're manually setting headers. We're saying we're going to set the primitive register. We're setting it to something. We're saying we're going to send color position data. We're setting up. We're just putting triangle data like right into a buffer here. So my thought is, and let me actually pull up a thing so that I can draw this, right? Let's get a new 3000, 3000. I should really start saving these things that I doodle while I'm talking. Okay, so. That's pretty good. Let's get a nice soft brush here. Beautiful. So. We have a GIF tag. Oh, we've got a buffer, right? It has a tag at the start, This tells us like what's in it, right? So this says color, position, color, position, color, position, right? And then we have color, position, color, position, etc. Right? And you can just repeat this over and over again for as many, well, in this case, we're kind of saying like this is one face, right? Like one face of the triangle, and then there's one set of 6 registers being set, color position, color position, color position. And then you can repeat that as many times as you like, right? So my thought is, rather than trying to have like an .obj parser, you know, baked in C, really awkward to do, really gross, you know, how do you actually store the model once you've loaded it, right? Why not just pre-process models from .obj and store them essentially in this format? But where I have position, where the PlayStation 2 expects, you know, an X, Y, and Z, or an X and a Y in fixed point, in a 16-bit fixed point format, why not pack into the 128-bit word X, Y, Z as 32-bit floats, right? And then when we draw, before we actually draw the mesh, you know, we kind of copy this to a new buffer, and then we step through, and when we get to a position, right, so we kind of know the offset of positions for each vertex, we step through each vertex, we get the position of that vertex, and we transform it from this into the representation that the GS actually understands, okay? And because this is what we're going to eventually do when we're rendering with VU1, right? When we're writing specialized vector unit assembly code, we want to do this transformation in place in a list that is already set up. That is the easiest way to go about it. You don't want to be, you don't want to be like reading a list and then dynamically generating another list. That's going to chew through a whole bunch of your VU memory. This way, you know, you kind of use like the same amount of memory. For you don't have to have double memory, right? It's going to save a lot of space, and it's going to save a lot of effort not having to actually parse object files or FBX files or anything else complicated in C, right? We can do all of that pre-processing, and so that's exactly what I've done. I've got a Python script. Let's obj to GIF. So I've got an obj parser. It's literally just like it goes through each line of an object file. It stores a vertex. It stores a face, or it's like, hey, I don't know what this other thing is. Normals. What are they? Who knows? And then all it does for each face in the object, it outputs 3 vertices, where each vertex has an X, Y, a Z, and for now, like a W component. I don't really know what I'll do with this in the future. Maybe I could like encode color in here or something. I don't know. It doesn't really matter. But for now, X, Y, Z, W, and W is always 1. So this packs the vertex data, and it's an inefficient packing, but it's a packing that we can pass directly into the PlayStation 2. Ideally, you would be dealing with like triangle strips or something that would save a lot of faces, but for now, we're just dealing with triangles. We're pre-processing them into really dumb files, and we are gonna, where at the moment we, you know, kind of step through and like build this dynamically, we're going to have this mostly fixed ahead of time and just copy the actual vertex data into it, and then step through and transform vertices from floating point numbers to fixed point numbers that the PlayStation 2 understands, as well as, you know, doing our like, going from model space into screen space, right? Doing our model view projection, matrix multiplications. I might pull in some PS2SDK functions for that. I do also have my own C math functions that I've used for this in the past, but they're a bit janky. Let me pull up an example on GitHub, because it's kind of funny, right? Like matrix, 4-dimensional matrix multiplication kind of sucks. So if we look at one of my PS2 draw examples, right? I've got PS2 math, and I literally wrote a Python script that generated this because it's just so error prone to try and do it yourself. So that's fun. So let's make a file called mesh.c, right? And we're just going to load in a bunch of dumb binary data. That's our goal, right? So the first thing we want to do here, we need to be able to actually load a file, right? So let's just write a nice little utility for this. Load file. So we're gonna, this isn't maybe the right place for this. We'll put it here for now. We're gonna treat the file as an array of bytes, even though it's really an array of like it's a list of vertices or a list of faces where each face is 3 vertices and each vertex is 4 floating point numbers. And we're also going to have the size of our buffer, right? We're just going to read this in as a dumb array of bytes. So let's fopen fname, and we're going to read it as a binary file. We need to get the length of the file. We probably should have a header at some point. For now, we're just going to seek to the end f, what is it? It's 0 set seek end. Cool. And the length is going to be ftell. And then we need to seek back as well, right? fseek f0, and this is where seek goes back to the start of the file, right? If our length is gonna overrun our buffer, then something's gone really wrong, and we're just gonna return 0 to indicate that bad things have happened. Then we're just gonna read the file, right? Bytes read, f read. Now the buffer comes first, then the size of the members, and then the number of things you want to read, I think, and then the file. Yeah, that's the order. Cool. And then we want to close the file and return that. Let's make this an int. I like ints. Ints are cool. Should be a size t. If you want to be technically correct, we'll make it an int. So now if this function returns 0, something's gone wrong. If we've read 0 bytes, like that's how fread indicates a failure. It returns 0 or -1. So if this returns less than or equal to 0, something's gone wrong. Cool. So I guess, yeah, the key thing is we need to actually be able to get a model, right? And so our model, let's call it a model. We might rename this later. For now, let's call it a model. It's gonna have a buffer of quad words, right? Because in our representation, we're using what's called packed mode. Each register is being set according to a quad word in this buffer, right? So 4 words, 16 bytes, a lot of data. We need the number of faces that are in this model. We need the number of vertices that are in this model, and that's actually just going to be face count times 3, but for now we're going to store those as 2 separate numbers. We also need to know the size of a vertex, right? So how many components does each vertex have, right? So in our case, we're going to be reading in a very simple list that will only have position data, but in the future we might have position and color data. So that'll kind of tell us, this variable will tell us that when we're processing our model and we're just looking for position, that we have to skip extra fields, right? And that means we also need to know vertex position offset. So if you've worked with like OpenGL, you know, you've set up vertex array attribute objects, vertex array objects, you've set like attributes in them with offsets, you tell it your vertex size, right? We're doing the same thing here, we're just doing it in a PlayStation 2 way. So we're going to have another function. We're going to say model init. We're going to give it. We are going to give it. What are we going to give it? Oh man. Do we want to call load file? Let's give it a file name. Yeah, let's do it. Const car. Let's call it model load then. We're going to have a file name. We're going to have a model that we're actually like setting these things into. And let's 64 uint 64 keyword t. Let's give it an RGB as well. Keyword t. Let's be able to set the color of our model. I think that's important, right? We want a very visual thing here. So we'll pass that in too. And we'll actually no, look, let's not pass it in because it'll just be a dumb field of our model and it won't really matter. So, and actually it's a double word, not a quad word. So it's a uint 64t. Perfect. So. We're going to do our favorite thing in the world here, and we're going to grab a quad word pointer called Q, which is going to start at our model's buffer. We actually need... we don't want to alloc here, so let's go model alloc. Or model init. Let's call it... I don't know. Oh, it's hard, right? Because we don't want to over allocate, but we don't know how much we need to allocate until we've actually loaded the file. So maybe the key is that we actually don't give it a file, we give it a buffer, right? We give it this. Right, so we'll call load file, we'll get the result in a buffer, and then we'll pass that in. That makes more sense. And so this is going to malloc, and we're going to accept that. We're not scared of malloc. If not m, first things first, if not m or not b or b len less than or equal to 0, then we're going to just return 0. This is a really primitive way of dealing with errors, but we're going to roll with it for now. Buffer equals malloc b len. Right, we need to be able to hold everything here, and maybe a little bit more actually, because so I'm debating if we actually put the whole GIF tag in this buffer. So, you know, do we put what am I thinking of? What am I thinking of here? Do we actually put like the headers that tells us what's in this thing? And I think the answer is yes. So I think we're actually going to have plus something constant. So we're going to add to the size of the buffer, right? And we're assuming this is going to be a multiple of 16 as well. We should check this. We'll check this somewhere else, right? But let's document that assumption here, because that's an important thing to do. blen must be a multiple of 16. Perfect. So we're going to keep track of this buffer, and we're going to start writing arbitrary GIF tag header information to it. So Q. And we're going to do this very similarly to like what we've done before. The first thing we want to do is set the primitive information, and I am going to try and remember how we do this. I think, is that enough things? 1, 2, let's start with 1 actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, is this it? Is this it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Yes, that is the correct number of bytes. Perfect. The first one is always the hardest to set up, right? You've got to kind of like fly blind with the number of bytes for a little bit, and then you jump in. Then you jump in big. So double word 1 equals. We're going to set the 80 registers. This is just all zeros and then E at the end. And we are going to set it like we were doing before, like we're doing in main. So let's actually jump over to main, see if we can't do some copy and paste, everyone's favorite thing. I should have copy and pasted this from the get-go. Perfect. So set reg via AD. And now we're actually going to set the color register here as well. So we need to change the number of loops, the number of things in here to 2 RGBAQ QDW0 equals GS set RGBAQ. Oh yeah, and we can actually do this from a look. Let's red, green. Let's do that. Let's do that. RGB. We have to set the alpha to something. We learnt in the previous episode that when you try and draw transparent triangles, it doesn't go well. And then this Q value we can pretty much just set to whatever. But we're gonna go with 80 for now. Beautiful. And then QDW1. We're telling it that we're setting the RGB a Q register. Beautiful. Q++. So we also need a Q++ here. How silly to forget. Okay, so we've got a gift tag. Now we need a second gift tag, and we're actually going to store this, store the address of this one, I guess. Q word T gift tag model, or let's call it vertex gift tag start equals Q. So we're going to remember this spot and then swiftly move on. We'll come back and set it at the end. And now we need to copy this buffer into Q, right? So mem copy destination is Q, the source is B, and the number of bytes is B len. And we're gonna, I think memcopy returns the number of bytes it writes, right? I'm pretty sure. It must. No, it doesn't. Interesting. It returns... Huh. Okay, it returns the destination. Cool. And that was definitely destination source. Yes. Beautiful. So Q plus equals B len divided by 16, I guess. So it really is important that this is a divisor of 16. Otherwise, things are going to get really wacky. So we've written the mesh data or the vertex data, and that's it. So we've got... This is like ready to draw, right? We could just kick this off and draw it, except for the fact that the vertex data is not in this correct PS2 format yet. We need to do a transform step as well, but we're going to do that each frame that we draw, and that'll let us do things like position the model, rotate it, scale it, whatever. Do fun things, moving it from model space into screen space. Cool. So now we need to actually like set the, probably, what you would say are the actual important fields, right? We've set all the junk ones. So the face count is going to be vertex count is going to be B len divided by 16, right? The number of quad words, for now we're going to say that every quad word is just a vertex, right? We don't have a header or anything to tell us any better. So that means that m vertex size is going to be 1, and m vertex position offset is 0. Beautiful. And the face count is just going to then be the vertex count times 3. Every face is just 3 vertices because we're drawing triangles. We're not doing anything fancy with triangle strips or anything. Then the calculation would be different. And then we return 1 because everything is A-OK. And that should be good. Oh no, hold on. Whoa. We missed something. We missed something important. We need to actually set this. So vertex gift tag start DW0. So we need to tell it what we're actually drawing here. Not only what we're drawing, but also that we're going to be finishing a draw with it. Oh no, we're not. This isn't an ender packet. This is fine. This can get mushed into something else. So the first double word is going to be how many registers? Well, let's start at the end. Vertex gift tag start DW1 equals. So we can only set this now because we need to know the number of faces in the model, and we only know that. Well, actually, we do know that up front. Interesting. I feel like. Actually, this is really silly. Why am I delaying this? I can work this out. Oh, I guess we can calculate this up front. We can do this all up front. We can do this all like before we even draw anything, right? So let's come back up here. Blen. We've got the length. We've got the length. Beautiful. Cool. So instead of just moving swiftly on, start vertex data gift tag. The first double word is a little bit more complicated. The second double word, this is just going to be the registers that we're setting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so there are 2 ways we could approach this, right? We could say we're setting the position, and then we could go 1, 0, 0, 0. This is the same number of things, right? And so I guess Q DW0 or equals. So in this case, we're saying that each like loop around, I guess, we're just setting the position register once. So we would need to do that once for each vertex. So we would say m vertex count and 0x2ff, I think. It's 14 bits, right? So 4, 8, 12, 13, 14, that's a 3. So that's how we could do this. The other way that I think will work, and I'm not sure about this, but instead of just passing in, like, it's like doing a vertex each loop, I think we can do a face each loop. And I think we could actually extend this as much as we want. But for now, let's just say face count. Oh boy, I hope this works. This is going to be hard to troubleshoot if it doesn't. So, yeah, and I think this is... actually, we can do this all in one line, right? I don't need to do this. M face count and 0x3ff. Beautiful. Beautiful. Oof, time is really flying here. Okay, so we've got this cool little model abstraction. We can return. We don't really need to keep track of Q anymore. Nice, nice. I think this is good. I think this is good. So, look, this function shouldn't live here, but it'll live here for now because this is the only place it'll kind of get used. Mesh.h if and def mesh h. And then we just need to drop these functions in. Okay, beautiful. So now we just need to rig this up. We're still missing the part that actually transforms this stuff from mesh space into screen space. I think we should be okay to just hook it up and run it and see what happens, maybe? Let's try it. Let's try it. So if instead here, okay, so if instead of all this, right? So we have our draw buffer, which is just used for like general shit. We're going to copy into this, so it needs to be a lot longer. Let's make it like, let's say we have enough room for, let's make it 8,000. 8,000 times 16. That's a lot of memory, right? I mean, it's not loads. Times 16 divided by 1,800 divided by 1024. Yeah, it's 125 kilobytes. So what's 160? Yeah, let's go. I'm trying to pick a very certain number here because I know one of my files that I want to test is about 300 kilobytes, which is massive, by the way, right? duh tpod.gif. Yeah, it's 300 kilobytes on the dot. So I need a buffer that will eventually be big enough to hold that. So let's think about that. Let's do some quick maths. 300 times 1024. I want to do this divided by 16, right? So I need enough room for, let's say a nice round 20,000. And so we also need to allocate that much in the first place. Beautiful, beautiful. So we've got a much better initialize. Now we just need to load an actual model somewhere in here. Let's go struct mesh. Did I call it mesh or did I call it model? I called the file mesh. And I called the struct model. That's hilarious. That is hilarious. Nope. And we don't give it a buffer, do we? So we say load file fname b len. So if not load file, let's use a magical constant for this. And then file load buffer len. We actually also need some way of like going to a fatal error, and I've got a fun idea for this. Load file load file s. Cool. Actually, yeah, let's pass in the draw context to our fatal error function as well, just to have fun. If not model load, I called this model as well, didn't I? Hilarious, hilarious. We give it our model, we give it our file load buffer. Actually, we need to get the result of this, right? So int bytes. Cool. And let's also check here if, because remember we have our precondition that bytes read has to be a multiple of 16. So if bytes read mod 16, not mod 16 isn't 0, we're also going to fatal error model file length of model file s was not 0 mod 16 tgt file. Beautiful. So now we check if we can actually load the model, and if not, we'll just give that a crappy message for now. That's fine, that's fine. And then I think we're pretty much, hold on, so once we've got our mesh, then yeah, we can just copy it into our buffer here. So let's do this the dumb way, right? Let's say, hold on, I should have some kind of buffer len as well, shouldn't I? Keyword t, not keyword t, sorry. Let's go int buffer len. And also, I almost forgot, mesh.c, we've got something constant. And this something constant is going to be whatever this is, right? So 1, 2, 3, 4. 4 quad words. So let's go define model buffer pre as 4 times 16 for 4 quad words. I need a drink of tea. Ooh. Ooh. All right. How are you doing? How are you doing? How are we finding this? We excited to see something hopefully more exciting than a triangle get drawn to the screen? It's going to be beautiful. It's going to be beautiful. Model buffer pre. Okay. Okay. Here we go. Home stretch. Home stretch. We also need to store the length of the buffer, and so that is going to be m buffer len b len plus model buffer pre. Okay. So we're gonna get rid of this draw cool. We're not gonna use that ever again, hopefully. Mem copy q. We're gonna copy whatever we've got in the model buffer, and we're gonna copy the whole thing. And then we're gonna say q plus equals m buffer len divided by 16. So we're going to advance it by the number of quad words that were in this buffer, which should be a nice even number. If it's not a multiple of 16, we've got a big problem. And then we can just draw that as we were doing before, right? This other thing I want to do, I want to have this fatal error function, and let's just like void spin, or let's say error forever. Right, I just want a function which like clears the screen to red and spins forever. let's just grab this whole while loop. And then we'll clear out. So DMA wait fast, yes, yes. We're gonna have a much smaller buffer. Hold on, this indenting is all wrong as well. Cool. So actually, we might need a little bit more than that. Let's say 1,200. Let's go. Yeah, let's give ourselves a bit of space. Cool. So what I want to do here, I just want a function which is going to spin forever but clear the screen to red. And that's going to make it really easy to... It'll make it easy to see when something's gone wrong. And then we're going to put a nice wrapper around this which logs a message and then calls this function and spins forever. That is the dream. The other thing I want to do here before we start actually is probably wait for vsync. Or maybe not. Let's just go straight into it. Screw it. YOLO. Also, let's get rid of this print buffer for now, just because this is going to be very, very... Sorry, they're very, very noisy when we first get into this. Okay. I think we're good. We need to define this target file constant. Host cube.gif. So one of the cool things about a recent PCX2 patch is you can use this host. So you can just load a file off of your computer. You don't have to like package ISOs and stuff. And so I need this fatal error. So it's going to be define st msg ... And this is going to be... It's going to do two things, right? So it's going to, let's say, printf and then va args, and then it's going to go error forever st. Perfect. I don't know, that felt like the right thing to do at the end there, just to make sure that it gets terminated. Cool. So, God, there's some janky stuff going on here, but I think this is going to work. I actually think when I run this, assuming it compiles first time, which it obviously will, let me just double check mesh.h. There's probably, yeah, I'm going to need define tam types.h. Tam types? Sorry. I lost my train of thought. Include tam types.h. That is the only thing I'm going to need, but in mesh.h I'm going to need, mesh.c rather, I'm going to need include tam types.h, include stdio.h. Oh, and of course, who could forget, everyone's favorite, include mesh.h. Okay, and this is going to build first time, mesh.o. Sudo make docker build. Cool. Okay, we got a few errors. Let's see. st is a here's a nice easy one to fix. Passing this in as a pointer, but reusing code that treated it where it wasn't a pointer. Dangerous. Very, very dangerous. Very easy to do. Cool, so this is now a pointer. I think that's the only place that happens, yep. Model load, it's because I, again, just didn't actually include my function. It's like I don't actually want it. Mesh. Cool. That still didn't look like too many errors. Main 133, 117, 130, oh yeah. Well, that's easy. I need to actually move this to the top of the file because C likes things to be defined in order. I always forget that. Cool, that still doesn't look like too many errors. Conflicting types for error forever. Previous implicit declaration, but this shouldn't actually like evaluate. Oh, it's because I'm calling it before. Yep. This also needs to go. this also needs to be defined at the top of the file, right? Otherwise, the first time it sees that, it might treat it as a definition, maybe? Things need to be defined in order, right? Invalid type argument, have struct mod. Oh, yeah. And then I'm treating this as a pointer all the time when it actually is not a pointer. Let's search for M arrow. It looks like it. An expansion of macro, fatal error, unexpected expression before. Expression of macro. Unknown conversion of type. Unknown conversion type character. That's weird. That is weird. File load buffer we need to actually define even bytes red. File load buffer expected. Okay, well let's clean up the easy ones here. 116 bytes red. God, I've been doing too much work in languages that don't demand semicolons. It's bad. Let's also define file load buffer, right? That's going to be easy. Let's do just like a stupid amount of memory as well. Let's do 300 times 1024 for 3 kilobytes. Let's do 310 times 1024 for 3 kilobytes. And then int file load buffer len equals 310 times 1024. We should really define these better, but again, this is just rough around the edges for now. Okay, so now line. It's because I've got this freaking modulo symbol. Of course. I think do you backslash it or do you double modulo? It's double, right? That's just 1%. Bytes red. File load buffer len is undefined. File load buffer len is undefined. File. Oh, weird. I must have actually accidentally undone that. File load buffer len equals 310 times 1024. And then expected. Oh, my VA args is wrong as well, isn't it? You've got to put the double hash in front of it, otherwise. This is just like weird C magic. Okay, now we actually get to mesh.c. And there's a bunch of stuff I haven't included. Mesh.c. We need include gsgp.h, I think. We need. Actually, maybe that's it. Oh no, we need string as well. Okay, we're getting close. Feek instead of fseek. We need stdlib. I think that's it. I think that's going to be it. stdlib.h. And then where is it? Fseek. And then just one last thing, and we are good to go. Oh yeah, just random stray curly brace, of course. Let's see what happens. Let's see what freaking happens. And of course it doesn't run, but it opens a file, it does something with it. It's thinking. It looks pretty good, right? I'm amazed that just worked. Hold on. The other thing to actually quickly check is that I have there's this setting called enable host file system. Yes. Okay. I mean that wouldn't have succeeded if where is it? Where is it? This wouldn't have succeeded if that wasn't there, but anyway. Okay, so what we want to do, we want to actually just add some like logging, and I want to define I want to just define some utilities for this real quick. MSG, and this is going to look a lot like the one from before. Printf MSG new line cool. this might seem kind of dumb, but it'll be fine. Mesh.c, we're gonna include log.h. Cool. So, we don't want to do it there. Actually, maybe let's put this in main. Let's put it in mesh.c so that we can see. Okay, info model. We want to know how many verts, how many faces, and how many bytes in buffer. Cool. So m vertex count, m face count, and m buffer len. Here we go, here we go. Then we're gonna run it, then we're gonna run it. Okay, that looks like, so the model we're trying to draw is a cube. So this doesn't seem right for a cube. A cube shouldn't have 108 faces, and actually, I realize exactly what I've done right away. Okay, so what should be a giveaway here, right? So if you think about what we're drawing, oh, my log's gone. If you think we're drawing a cube has 12 faces, and 12 times 3 is 36. So there should be 36 vertices, but 1/3 that number of faces. And what I've actually done here instead, I have multiplied by 3 to get my number of faces. Where are we? Face count divided by 3. So let's try this again. It's weird because it looks like nothing is being drawn here at all. But this looks correct. This looks correct. Okay, so now we're going to come back and we are going to do everyone's favorite. We are going to just dump our whole buffer out to the log. Is this C++? This is hardcore pure C. What is it? Shistano? This is just straight C. I'm not a huge C++ fan. I'm not a huge OOP fan in general. So I just like smashing stuff out in plain C. I think C++ does have some advantages in certain places, but you can write some really beautiful, elegant, pure C code. I'm going to also increase this sleep because otherwise we're going to have a lot of log spam. So let's go over to PCSX2. Let's see. And it looks like nothing got printed, which is weird because we definitely told it to print our buffer. So, draw from buffer with length. Let's see what the actual math says. If we're trying to draw a zero length buffer, that would explain a lot. Oh no, here it is. Okay, so let's see what we've got in this buffer here. This is going to be fun. So we're setting something via AD. I don't know what 47 is. I don't know what register that describes. We're setting two things via AD. We're setting, I think this is setting up primitive stuff, and then this is where we like clear the screen. So what I want to really look for, this is the finish packet, and then this should be our mesh data. What I want to find is here. Wait, hold on. This doesn't look right. Oh yeah, no, yeah. This is the start of our GIF tag, right? So we're setting. Oh, this is wrong. This is the wrong GIF tag. We're saying that we're setting one register, C times 12 times. Yeah, that makes sense. 12 faces. We're doing this 12 times, 3 vertices per time. But actually, we need this to be a 2 because we're setting 2 registers. So that's something that's easy to fix. We're going to go into mesh.c. We're going to find where we're grossly manually setting setting up our GIF tags. We're going to jump to this 1. We're going to turn it into a 3. We're going to make, and then it's going to work. Okay, so I don't know if you can see this as well as I can, but you can see from the letterboxing, we're actually clearing the screen now. We're actually drawing something. So that's good. The draw actually goes through, and I suspect the fact that we're drawing a model which lives in like model space, which is probably, you know, in a range of like, oh no, well hold on, we've still got floating point numbers. We need to convert floating point numbers into fixed point numbers. I forgot. I missed a step. Hold on. Whoa. Where are we? Main.c. Okay, we're gonna do this quick. I'm getting tired. Got to go to bed soon. Gonna smash out a quick transform. Okay, so void mesh transform. We're gonna take a mesh in. We're gonna take a model in rather, and we're gonna take a buffer, which is where this data starts in the draw buffer. This is gonna be janky as hell. We're gonna come up with a better abstraction for this eventually, but for now, for each vertex I less than m vertex count I plus plus. We need some more parameters here as well. We need like a center x. We need let's just take one scale parameter for now, and then let's take a float translate x, float translate y. Okay, so we're not going to do like 3D maths on it yet, but it's going to be a start. For each vertex, oh boy. For each vertex, we have, so let's say we want to stride, right? We want to walk through this list of vertices, and we need to know how big a vertex is for that. So our vertex is m vertex size mesh.c, because we're treating this just as a list of bytes, right? We're not doing anything too fancy with this. I want mesh.h, sorry, vertex size. So each vertex is this size times 16, right? Yeah, because yeah. Okay. So each vertex. So let's say, so it's going to be stride times, so equals b plus stride times I. So this is where our vertex starts. The position within this then has a further offset. So char equals v start plus m vertex times 16, right? Because again, this is all quad word world, right? So vertex plus, and so now from pos, if we interpret pos, let's this is pretty janky. Let's actually let's cast here. So on this side we're dealing with byte indexing, then suddenly we're going to jump into float world, and floats, you know, are 4 times the size of a byte. So indexing is going to be different. So we have to do all this maths while we're still wearing our byte hat, right? And actually we can collapse this all down to one expression. So v start, I don't know if it's more readable here without this, but let's say b plus stride times I plus the position. So get vertex. Oh, hey Knight, how you going? Knight, you're doing computer science stuff, right? You've like, God, you would have like started uni absolutely by now. Hey, it's been what, 2 years or something? 2nd year, man, wild. Time flies. Holy crap. I was thinking the other day about KuachiCon. That was, yeah, it was a good time. Are you doing much C in your software engineering? How much weird pointer hacking do you do? Cool. So get vertex offset. Get of current vertex. That's a bit of a nothing comment, but we'll survive. So now we have a vertex, right? So let's grab the x from it. Equals pos 0. Y equals pos 1. Float z equals pos. Nice, you've done a bit of C. Yeah, a lot of C stuff they give you at uni is very like, I don't know. I found it very box checky. Like they don't really teach you how to do C. They teach you how to. They're like, this is a pointer, and then that's about as far as they go. But it's cool. It's a really cool language. It's good. It's good to have up your belt, and it's fun to do. Like so. This is PlayStation 2 stuff. This is essentially an embedded system. So there's no operating system or anything. I've kind of showed this a few times, right? But if you just you can just pick any address, right? So like I can say the address 12345. If this is if this is in the range of the MMU setup for the PS2, I just own this address now and I can do whatever I want with it. There's no operating system to say no. Awesome. Shistano, cool stuff. You've earned a follower. Thank you so much. Nice. Yeah, no, seriously, like everyone should learn to program, no matter what your background is. My background's actually in music, right? I came from being a musician into the wonderful world of computer science. People are super cool. Everyone is really awesome and helpful, and there's lots of really great knowledge out there and really awesome people who, promote really interesting content, right? If you want some people to watch, look at Code Parade on YouTube. And look at, like, Ben Eater, I think is really good. His stuff is more, like, electrical engineering, but just, like, really cool projects that are really inspiring. And there's a guy, Sebastian Lauge, really cool YouTube videos where he just, like, builds things that are interesting. Awesome. Yeah, no, thanks so much for stopping by, Knight. It's really weird having Quake people come in and watch me, like, talk about programming, but I love it. I love the crossing of worlds, and yeah, definitely check it out. It's going to get more visual and less bit hacky as we go, hopefully. Which will be fun. Lines like this don't make me happy. So if I can come up with better abstractions that kind of hide some of this magic, and I can actually talk in like higher level concepts more, that'd be really cool. That's the eventual goal, but it'll take a while to get there. So I'm going to try and get something on the screen. I'm going to try and get something more interesting on the screen. Okay, so we're going to do I'm just talking about evil bit hacking. Get ready for a line, because we need to set this now as an integer. We need to convert a floating point number into a 16-bit fixed point number, and for the sake of convenience, we are gonna cast to an integer to do that. So just deal with this. Just deal with this. We wrote a function in a previous episode called myf2i. This lets us convert from an integer or a floating point number into a fixed point number, which is just the format the PlayStation 2 GPU expects it. And so this is going to be, we're going to have our x times our scale plus our translation. And then we're going to add our center x onto that. Our center x is already converted into this fixed point, so we do it outside of this call. And we're going to define this and pass it in as we see fit. So t row plus 1. Oh dear. Some of this casting is probably a little bit unnecessary, but I just want to be really sure. And actually, sorry, it's called pos, not row. I'm kind of thinking of it as like a row, right? As like a row in a table almost, but we're calling it pos. Also, this is probably unnecessary, but I think it makes things a little bit more readable. You can kind of see, like, we're taking this position, we're reading it out, and then we're bit hacking overriding it with something the PlayStation 2 actually expects to see. So we're turning a nice floating point number that we like into something the PlayStation 2 wants to do with. And then we're going to do the same thing for our Z, but we're going to do it a little bit differently. uint 32t pos plus 2 equals. This is going to be very different. I think this still expects fixed point. I'm not totally sure actually. Let's do it anyway. My f2i, and we'll just make it z, right? We don't need to cast that. We don't need to cast that. Cool. So, and then row 3 is we're just gonna zero out. And actually, like, GCC is going to give us a warning if we leave this in here. So we'll get rid of the unused variable. So we've taken a nice floating point data, we've converted it into something the PlayStation 2 expects to see. And now when we draw it, that should work a little bit better, hopefully. Let's put that in here. So I've copied it into our buffer. We've finished off with our buffer, and now model transform. We need to remember where we've copied it into. So let's say keyword t m. I think we said model first, then model verts start, and then we've got center x, center y. That is fine. My f2 i4 2048, my f2 i4 2048. Again, last time we played around with these offsets a bit and learnt that it's kind of important to set them to 2048 to represent the middle of the screen. And then what else do we have here? Draw. We don't want. Yeah, cool. Okay, so I don't think I left a line between these, so it's. Oh no, I did. Scale tx ty. So scale is going to be like 3.0, tx can be 0, ty can be 0. Maybe like 20.0 even. F. Okay. Let's see if that works. What happens if we make this? This is going to complain because mesh.c doesn't have some of the model transform. Did you mean mesh transform? Yes, I did mean mesh transform. Row undeclared. Yes, of course. And it needs my f2i as well. And also I misspelt vertex. Okay, so let's start with mesh.c. Let's just copy and paste this for now because it's a bit of a nothing abstraction, I guess. As it turns out, the fixed point representation, the bottom 4 bits are the decimal part, so if we just shift an integer by 4, it's fine, and we just basically obliterate the need to consider this. Vtex. Oh no, that was in main, wasn't it? Vtex. Vertex. What was the other thing? Model. It's called mesh. Model. Mesh transform. Cool. Few issues. Oh yeah. My f2i. God, I keep forgetting that's in i4. Where else did we have an issue? I called this row again, didn't I? Pause. Cool. Float and int. Weird. Okay. Hold on. Yeah, I think I actually need to cast down. Where do I cast this off? I cast this off. Yeah, so I need to cast my integer, my floating point to an integer and then left shift it. And that works with a warning. V-start. Oh, we can clear that up as well. Also, apparently incompatible. That's fine. We can do with that. But I'll clean it up. I'll get rid of the warning. I'll be explicit. We are passing this as a pointer of bytes. We don't care about the fact it's a quad word. We just care about the memory address. The other issue, what was it? V-start. It's gone. Okay. Builds, no warnings. Make, run. Let's see what happens. I feel like we're making progress. Draw from buffer with length 75. It looks like all the right stuff is here. Should I make it bigger? Should I make it bigger and play with the Z? I feel like that might be the way to go. The other thing, actually, there are two things I can play with. Draw finish, buff downstairs. Cool. Emphasize buffer length divided by 16. That's correct. Enable. So what are we? What am I missing? I wanna try using a different Z scale because I don't know if I actually need to shift the Z over like this. What if I just like put the Z in? What if we just keep it, but like cast it to an int? It runs. Interesting. All right, well, let's just quickly check. I'm probably going to have to call it there. Let's just quickly check these buffers and see if there isn't anything obvious to do. Actually, there is one more obvious thing I can do. There's one more obvious thing. I'm looking for 5555. 5555. Where is it? It's going to be like 12 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Interestingly, we may not have a header for our gift tag, or we may not have anything in here actually. Is this ever draw buffer with length? Hold on, that is not the right buffer. That is not the right buffer. Mem copy m dot buffer and buffer length. M dot buffer len. Let's just make sure that actually copies literally anything. Where are we? Copied with length 640. Yep. But that's definitely not in there. It's definitely not in there. Oh. Oof. All right. Let's see. It's got to be something. Easy. Why isn't this copying properly? So if I go into mesh.c, what is here? mbuffer. I definitely call mesh load. That's worth checking. The other thing is I could just try and like transform this in oh wait, hold on. It's because we're just working model vert start. Yeah, it needs to be model vert start plus whatever our offset is, and I think our offset in this case is 4, right? So we have 1, 2, 3, yeah, 4 double words. So this should be better now. And there we go. We've got a freaking cube. All right, let's swap this out for the Utah teapot and see how we go. That is freaking awesome, man. That is loading a file from indirectly from a .obj, right? Let's go target cube. Let's change this to teapot.gif. So this is the Utah teapot. Hold on, no, we still need to recompile to change the model, unfortunately. If I renamed it, okay. Maybe, hold on, let me change the scale of that a little. And this is the cool thing, right? Now we're actually loading files a bit more dynamically. We can come in here and say, hey, let's scale this down a bit. That was probably a little bit too big. Make a run. Oh wait, no, hold on, that's our error screen. Length of model was not 0 modulo 16. Oof, that's an error and a half. Okay, well, it liked the cube file. Let's go back to that. Cube.gif handled very well. And so now next time we're going to do some 3D math. We're going to make this cube spin around, and we'll probably do some lighting as well. So this was progress, okay? I mean, look, we've gone from everything being in one gross file, we've split things out, nice, we've refactored, we now have an abstraction for an actual 3D model, so we can start to do things. Off camera, I'm probably going to extend my script. I'm going to try and convert maybe FBX files, maybe like other 3D models, because I can't find a lot of interesting 3D models in .obj format. I might try and make some 3D models, I don't know. I'll have some interesting stuff to put on the screen. But yeah, we'll try and get some like rotation and stuff, some lighting. We'll do some real 3D math. It's going to be real exciting. So thank you so much. Be sure to tune in for more exciting PlayStation 2 homebrew development and other programming stuff. I've got a YouTube channel now. It's all linked in my Twitch description. I've got donation stuff sorted on my website. If you do, for whatever reason, decide you want to support this show, maybe support me, getting a PlayStation 2 hooked up to my computer, getting a capture card and stuff to make all that happen. Feel free to throw me a bit of money if you're enjoying the show and you would like to see some of that stuff. I would love to get this running on real hardware at some point. And I will be verifying that this stuff does run on hardware as I'm going. It's just not convenient for me to plug my PS2 into anything right now, and I don't have a capture card. So, I have been Tom Marks. This has been a fantastic stream where we've made a lot of really wonderful progress. We've had some great people stopping by in the chat. Thank you so much, everyone, and I will catch you next time.